Welcome to MrCScience.com's video on experiment 2.1 for physical science. What we're going to do is we're going to do a little experiment on evaporation and temperature, kind of related to the humidity you were reading about. We're going to show that as water evaporates, it takes temperature and cools you down. So what we're going to do is we're going to take two thermometers here. You can kind of see where we're reading them and the bulbs kind of, but I want to get a nice close-up so we can see that temperature there. We're going to take one thermometer, we're going to put some damp cotton balls on the end of the thermometer. The other thermometer we're going to leave alone, and we're going to turn on the air and watch the temperature change. We're going to write up this experiment just like we did the other one. We're going to write them up like you would in college, pretty much. Not quite as complete, but the same general syntax. So again, get your lab notebook or a clean sheet of paper or a Word processor and open up a new page. Okay, we're going to start off with the title. Every lab should have a title. Title of this one is Evaporation and Temperature. Okay, under the title, Roman numeral number 2, period, we have our purpose. Every lab should have a purpose, and our purpose is to demonstrate how evaporation affects temperature. Is that effect, effect? Yeah, that's effect. Okay. Roman numeral number 3. Oops, not 3, IO plus. Let's see, 3. Hypothesis. Every lab should have a hypothesis. A hypothesis is an educated guess on what's going to happen. Okay, you know what happens when you sweat, you stand in the wind, what happens? You cool down. So our hypothesis here is evaporation. Oops. Come on, you can do it. Evaporation will lower the temperature. That's our hypothesis. Okay, Roman numeral number 4, materials. Again, we're not going to go into an exhaustive list here because we don't need to waste our time doing that. If you were doing a real lab, you would do a very exhaustive list in case you find something interesting. Ours are almost always going to be as per text. Okay, Roman numeral number 5. Procedure. Again, this is a exhaustive list of how things are going. Ours will most of the time be as per text, but I'm going to add with additions from instructor because I've added some things to your lab, and we'll talk about that in a second once we get going. Roman numeral number 6, observations. This is where we record our data. Okay. So what we're going to do is we're going to take our thermometers. We're going to record our starting point here in a second. Looks like they're both just 20 degrees Celsius. They're just a tick over. Your book will tell you to estimate within 1/10 of a degree. In real life, that's not how it works. Usually in real life, you estimate halfway in between what you can measure. So every degree on this thermometer is 1 degree centigrade. So we can measure within half a degree. So if we look there, it's not quite up to the half. It's probably closer to the 20. So our starting temperature for both of them is going to be 20 degrees Celsius, 20 degrees Celsius, 20 degrees Celsius. So let's add that to our lab. So starting temp, and we'll do wet 20C, dry 20 C. Now actually let's talk about why I added the second thermometer. The second thermometer here is called a control. We're going to put the wet cotton swabs on the one thermometer. Okay, the thermometer we do not put any cotton on will be our control. A control is something where you don't change anything. You don't add the variable. We're adding the variable of moisture to this one. So we're going to leave this one dry. Why do we do that? Well, what happens if during the experiment the temperature in the room actually goes up instead of just in that area? Well, then our thermometer would go up, and that would make us question whether or not evaporation added heat or removed it. So we've got something to compare it to. So if they both go up, then we'll say, oh, the control went up, but overall, taking that into consideration, the other one went down. So we're going to go ahead and do that. As well, I'm adding to this a fan to add a little air flow. Otherwise, it can take quite a while to get done. So that being said, let's record our starting temps. It's 20 and 20. Or did we already do that? We already did that. Look at that. So after we're done with the experiment, we'll record our ending. Oops. I can't type. So when we're done, we'll record our ending temps. So let's go ahead and pull the trigger, get started. So let's go to here. Let's grab our, you can't see me, grab our cotton swabs. Okay, wring out some of the water. Put the rest on there like that. There we go. Now let's turn on our fan. Okay, our fan is going. And let's watch our temp. Let's see if our water really was room temperature. It looks like it wasn't. It looked like we went up about a degree here. But we're going to let the fan do its work, and we're going to watch what's going on. I taped down our plastic so it will not blow over our experiment. And now it says give it about 3 minutes. We're going to give it a little longer than that since we got the time, and I'll probably stop the video along the way at periods and then start it again to show how things have changed, because otherwise it'll be boring just watching the fan blow on the thermometers. Okay, we saw an increase up to about 21. Now we're heading back down to 20. It's only been about a minute, so we'll give it a little bit longer. How does it look like? It's already going down. It's almost down to 20. So we see it going down. Our control is staying put. It's not moving. So we're blowing room temperature air around, so it should not reduce the temp on the control. Let's give it another couple minutes. Okay, it's been a couple more minutes, and you should see that we're quickly approaching 19 degrees. So we went up almost 2 degrees, and then we're dropped one below where we started. So just the even though the water was slightly warmer than room temperature, it's still going down. So we're down. We're about 19 even now. So I should have a video where I can do the fast forward and you can watch it slowly and quickly go down. But rather than waste a lot of bandwidth, I'm going to pause for another couple minutes and see what happens. Okay, it's been a couple minutes. We've only dropped about another half a degree. We're heading towards 18. Should answer a question that you might have. Why the fan? As water evaporates, it changes into a gas. If we don't move the air around the thermometer, the relative humidity near the thermometer will increase more than the area around it. So if we continually move that air out, then it doesn't have a chance to increase that relative humidity. And the higher the relative humidity, the more difficult it is to evaporate water. So, well, we've dropped down to about 18 now, so we're seeing it go down. So that's good enough for now to show us what's going on. So let's go back to our lab. Okay, so our wet final reading was 18. See, oops. Come on, there we go. 18 degrees Celsius. Our dry, or our control, I didn't even look at it. Let's go look at it. Our control is still, oh, hey, get out of the way. Control is still 20 degrees. It might have dropped just a hair, but it's still close enough to call it 20 degrees. Okay. Any other observations we should make? Other than it's cold me sitting next to a fan when it's only like 50 degrees outside, so but that's not relevant to our lab, so let's go ahead and go do the most important part of the lab. Roman numeral number 7. Conclusion. Why is this the most important part of the lab? Well, it's worth half your lab grade, so if you forget to do it, you've lost half your lab right there. So, okay, so conclusion. What do we do in our conclusion? First thing we do is restate what happened. The temp on the wet bulb decreased. We're talking about an overall decrease, not the little bump up at the beginning. While the control, our dry bulb, stayed the same. Okay, so we've addressed that. Now we address our hypothesis. Our hypothesis, evaporation will lower the temperature of water. So, evaporation did lower the temp. We don't foresee anything else lowering the temp because we had our control there. Otherwise we could say, well, maybe the table was cold, or maybe the room temperature dropped, something like that. So our control allows us to say, no, that didn't happen. So evaporation did lower the temp, and our hypothesis was correct. Okay. Beyond that, we could state how any practical uses or any questions that brought up about further experiments. Sometimes when I do this experiment, I like to also have an alcohol thermometer, one with alcohol on the outside instead of water, and kind of watch and see what happens there. It's kind of interesting because alcohol evaporates more easily, so it drops faster than the water does. But we're not going to do that today, so if you wrote down everything right here on the lab, and if you didn't, that was your chance to pause the video and do it, you've got 100% on the lab, so hey, easy A. So, and you learned a little bit about evaporation and temperature. If you have any questions about this, feel free to contact me at Mr. C at MrCScience.com. Thank you.